Okay, so what I want to take you back to now is just a wee bit of Unit 2 work, just to remind you of something that you should already know. So we're going to look at some reactions of aldehydes and ketones next. But before we get on to that, we really need to just refresh our memories as to what we know already about them. And hopefully from Unit 2, what you'll be remembering is that aldehydes and ketones come from the reactions of alcohols. This would be a primary alcohol because you can see there's just the one R group there. A secondary alcohol because you've got two R groups, and a tertiary alcohol because you've got the three R groups there, and of course your hydroxyl on each one. Okay, so those are your alcohol groups. Down below is the reagent that you would use, or the formula of the reagent that you would use to convert these alcohol groups into aldehydes or ketones. And I just want to remind you then that a primary alcohol can be oxidized by this substance to make an aldehyde. So see if you can remember what it is. It's potassium dichromate, and it's an oxidizing agent. Okay, now whenever these substances get oxidized, there's a color change in the dichromate from orange to green. Okay, and you've all done that experiment, you've all seen that happen. Okay, so if you take a primary alcohol and you reflux it in a water bath there with your potassium dichromate for a little while, then you'll find that you should have like an appley smell, and you should be making an aldehyde. Okay, and from the wee bit a moment ago, remember the aldehyde has got that C double bond O on the end. Okay, then you've got your secondary alcohols there. Okay, and they can also be oxidized. Okay, because they've still got space to be oxidized. In a sense, it's sort of removing oxygen, I suppose, or sorry, removing hydrogen. You've got your secondary alcohol here, and if you're refluxing it with potassium dichromate for a while, this time you're going to make the ketone. Okay, and again, this time the ketones tend to be stronger, smelling like nail polish remover, that kind of smell. It would be propanone. So one more thing to say, these aldehydes can be oxidized further if you can remember to make, it's getting a bit messy now, to make a carboxylic acid. Okay, so you can have a further oxidation there, and hopefully again from Unit 2 you'll remember that if you want the aldehyde you have to distill it off as it is formed. Okay, so a good bit of revision there on some of your Unit 2 stuff. The ketone, though, once you get to that stage, there's no more oxidation that can happen. Once you've made the ketone, that's the end of it. Collect it, end of story. This one, though, your tertiary alcohol, you can't oxidize it at all. So there's no oxidation that happens there. No carbonyl group can be formed from that. Okay, we've already said that you get your colour change from orange to green. What I want you to do now is to see if you can remember the little redox equation, the redox half equation for the dichromate. Okay, so maybe you want to pause this for a wee minute, see if you can remember how to write it, your Cr2O7 and what it's converted to. I've already done that for you down below. So this is all revision of Unit 2. So you've got your Cr2O7 2 minus being converted to your 2Cr3 plus, and basically once you've got to that stage you can work out the rest with your water and your balancing and so on. Okay, so let's think a wee bit then about the carbonyl groups themselves and what reactions can happen. So basically what we've just said is that from a primary alcohol you make an aldehyde. So in theory you should be able to do the reverse. By reducing the aldehyde, you should be able to return to that primary alcohol. Likewise, you should be able to take your ketone and return to that. And you'll find when we get to the end of all of this that you've got a lot of interlinking pathways and things where organic substances can be interconverted from one to the other. So in theory, this should be able to happen. We already know as well now that an aldehyde can be further oxidized to an acid. However, a ketone can't. Okay, again, looking back to Unit 2, there are a couple of reagents that help us prove that this happens. And we'll take a wee look at that now. So we're now taking a look at, on your notes, reactions of carbonyl compound. That is on page 15 of your notes, okay? And we'll just take a wee look at how to write the equations and things for that. Okay. Alright, so the functionality of these compounds is all to do with that again, okay, your polar carbonyl group there. But initially we're not too bothered about that because we're just going to look at oxidation for now. And the oxidation reaction goes in the following way. If you have got an aldehyde, okay, remember you've made it already from a primary alcohol, you should be able to oxidize it, and in doing so you'll make a carboxylic acid, okay? And I'll zoom out a wee bit so you can see. So basically the only area that's changed is this hydrogen has become an OH, converting that from an aldehyde into a carboxylic acid. Naming it then, if you start with ethanol, the corresponding carboxylic acid is just ethanoic acid, okay? If it was propanol, you would be making propanoic acid, butanol, butanoic acid, and so on and so forth. Pretty quickly in the lab, you would know that that had happened because you would smell it. So this one would smell sort of appley, like pear drops even, and this one would have a strong smell of vinegar. And you would know that the oxidation has happened. You'll notice on the arrow I'm just using that O in brackets to represent the oxidizing agent, and that would be your potassium dichromate. One further thing to say on that then is again talking about the reflux that you need to do in order to make that oxidation happen, and also you would usually need to acidify the potassium dichromate as well, okay, in order to get that to happen. Okay, so that's fine, but you can actually test for that happening as well. Maybe you'll remember from last year, I have a wee photo of it here, which I'll flick up. I'm not sure how well it'll come across there, but if you can see it, oh gosh, can't really see it at all. But that is basically a picture of a test for an aldehyde, and this uses Tollens reagent, which is the ammoniacyl silver nitrate. If the aldehyde is oxidized to the carboxylic acid, in return the Tollens reagent is reduced and you get this lovely silver mirror. I can't remember if any of us managed to actually get it last year, but you can get a really, really excellent result if you have everything right. Okay, so let's take a wee think about that.